Hello, welcome to our presentation. My name is Tim Lewis, and this is Stephen Hall, and we're going to be doing on kites and sims. Um, I'm a math teacher, and I'm also a math coach for the county. Steve?
I'm a science teacher and a math teacher. Our mentor is Mike Conroy. He is a NASA engineer who's involved with the Distributed Observer Network and the Eve and Steve software. They use software that is for video games to do engineering simulations.
The overview of the lesson is to focus on kites and simulators and how to predict outcomes. Computer models are needed to look at what is generated and what is the actual data, and compare the two. We're also going to engage students in the engineering process design, and by engaging the students, we really want them to get involved in their learning, and also to provide some authentic math applications, because we as math teachers and science teachers hear this all the time. How does this relate to the real world? How can we use it? And by using these simulations and showing them real relevant examples. We're going to talk about the engineering design model and also how to calculate the height of the kite using various methods, Pythagorean theorem, sine and cosine. And we're going to have them create scale drawings. Now, the reason we're going to have them do this is because looking at the data from our test scores, we realize that our students really are deficient in proportions and ratios. So by creating scale drawings of kites or other objects, it's going to strengthen their skills. We're also going to use the NASA simulator that simulates kites, compare actual data with simulated data, and compare the two. And we're also going to have them work in teams, because we all know that in the real world, we work with teams every day, and it's very important that you can communicate with people, you can work with them. You might not agree with them, you might not agree with what they're saying or the approach they're taking, but ultimately you have to work as a team and come together. The other thing is, you really want to take this technology and we want to leverage it. We, as teachers, we leverage technology every day. We're always looking for resources that we can use. These sims, all of these sims that have been presented today, are free, and we're going to use this to increase our student learning and get them excited about it, because one of the things that's lacking is students' excitement. Many times students just want an answer, and by using these simulators, we'll provide them with the use of some good technology. Introduction to the unit. One of the things with the kite unit is that you first have to decide, do you want to build a kite or do you want to purchase the kite? Now there's different advantages to both. One advantage to building the kite is you can develop their skills to measure objects, to create things, to test it out, design and construct them. The advantage to buying a kite from Walmart for $4 or $5 is that because we're so crunched for time in our classroom, it's a lot easier sometimes just to give them the kite and say, let's go test it out. The other thing we'll do with our lesson is we need to inform our parents about the project. One of the things we like to do is send a letter home or emails telling the parents about the project, what's involved in it, looking at how it's going to be graded, and also giving the parents some due dates or timelines so that there's no surprises. And the other thing about sending a letter home or communicating with the parents is that you get parental involvement. Come on out, help volunteer for this activity. We're all looking for parents to get involved in their child's education. And one of the things, being a Title I school that we are, we're encouraged to get that involvement, and this is one way that we can do that. we're going to use a kite simulator. This one we found on the NASA website. And we're also going to use Excel to put the data in and create a spreadsheet so students can analyze it. Some of the things that we're going to focus on is the forces acting on a kite, the lift, the drag. We're going to use math equations. Again, this stuff will have been covered before we get to the actual flying of the kite. We're going to look at the Pythagorean theorem, sine and cosine to find the height, and also the engineering design process. We want the students to think, use reasonings. We just don't want them plugging and punching a number and flipping to the back of the book and seeing if they've got an answer. We want them to actually think about it, because we know as teachers one of the biggest things that students aren't doing is they're not thinking. And if we can just get the students to think about the problem, analyze it, look at their results and see if their results make sense. And if we can get them to think, we're leading them in the right direction. Here's an example of some of a diagram of a kite with the forces acting on it. One of the things about this lesson is that this is very scalable. You can use this from a 6th grade class all the way up to an advanced class. It's just not tailored for one group. You can also use it in your physics class, or you can use it in your math classes. So you can just focus on, maybe for your lower level learners, maybe just the wind. For your higher achievers, you can focus on the center of gravity, the downward force, the lift. So we feel that this will really help engage a lot of students across the spectrum. I'm sure you've all seen this diagram. It's just a picture of a right triangle. Just showing you, here's the string. We're going to measure the height, and knowing some distance, we can calculate it. Here's the engineering model process. And again, we're just trying to get the students to really think about how to solve a problem and what steps to think, just for students to think, to analyze something, come up with a solution, see if it works, test it. If it doesn't, move on, try a different approach. Here's the kite simulator. This simulator is really neat in that it allows us to enter in data, change data, and simulate the flying of the kite. You can change the construction of the kite, the design of it, the material of it. I know you can't see the fine details of it, but you can change the wind speed, increase the angle, and just see what happens. And initially what we would do is we would have the students kind of just mess around with this or play around with it, put in some values, get a feel for how it works, and then we would give them, here's what we want to remain fixed, and here's what we want you to change. And so one of the things we're going to have them do is change the wind speed, keep everything else fixed, and change the wind speed, and do it in increments of 2 miles per hour. They're going to record that data in a spreadsheet, and then they're going to analyze it. And when they analyze it, and they use some of the math functions in Excel, they're going to come up with a curve like this. And we know it's not linear, but some of the open-ended questions that we're going to ask our students is, why do you think it's not linear? What are some of the reasons it's taking that shape? And as teachers, we always encourage our students, or we always try to ask open-ended questions. This allows the students to start thinking on a deeper level and just not giving a yes or no answer. And so by looking at this data, they can kind of make predictions as to, well, what if I changed the wind speed to an extremely high rate, what would happen. And so they're going to use this to analyze the data.
Okay. At this point, the students will be actually flying their kites. They'll be outside. The teacher may have decided to buy kites, or the teacher may have decided to build kites. And the students will be out flying their kites. You probably want to give them at least 15-20 minutes to fly their kite, to kind of get familiar with the process. I went out and flew a kite, and it took a little while just to get used to it. Every kite has its own personality. And so at that point, then you can start them on the actual math part of this assignment, which is that we want to calculate the height of the kite. So they're going to take a protractor with a plumb bob, or they could use a cell phone app that involves just tipping the cell phone and using the cell phone sensor to calculate the height of the kite. And we'd also like them to find the horizontal distance from the person to the kite using sines and cosines. The second part of that day's assignment will be to drop something from the kite. So what the people can do is make a release mechanism attached to the kite. What we did is use some double-sided tape and some string, and then stuck a ball on top. And so when you pull the string, the ball comes off. And by timing the height, timing the distance, by finding the time it takes to get the ball to the ground, you know the distance. And then finally, we'd like them to record all this data, to look at it and say, hey, does it make sense? How does it compare to our simulator? And we want them to get an idea of what a reasonable answer is and what it isn't. Okay. Here's a diagram illustrating the different parts of the triangle and how it relates to the math class. Of course, we have an angle here that they're going to be measuring, and the string length is r, our horizontal distance is x, and our vertical distance is y. Okay. At this point, this may be like another day's activity. This is phase 3. Again, the students are going to be outside, they're going to be with their kite, but they're going to be doing target practice. We didn't want to use the word kite bombing, so we called it target practice. But they're going to have a target on the ground, they're going to try to hit it from their kite. So they'll be having a ball on the kite, and they're going to release the ball over the target and try to hit the target. And we want them to use math to be able to find the correct distance. So we would start them at a certain starting point, say, okay, it's 512 feet or something like that to your target, downwind, and then they would have to use math to calculate the amount of string that they have to let out. For the second part of that, we want them to use a cell phone. Now there's two ways they could do that. They could put the cell phone on the ground and look upward and just fly the kite around until they see the kite, or actually mount the kite with the cell phone. And so there's two different ways they could do that, and if they did that, they could even utilize GPS data if they mount the kite with the cell phone. Here's a video. We tried it. I'm a firm believer in not giving advice that I haven't done myself, so we went out and tried the experiment ourselves. We did all the things we've been talking about here. And this was the cell phone sitting on the ground, and then I just clipped to the part where the kite flew over. I didn't think you'd want to sit through the whole...
I don't know.
Do what?
I was going to say play it again.
Oh, play it again? We can play it again. Sure. Yeah, it was a pretty quick little video. I clipped out the rest of the video. I didn't think you'd want to sit there for 5 minutes looking at a blue sky. That wouldn't be very exciting, but anyway, that was the highlight. So this is a real easy application for students because a lot of them have cell phones with cameras on them. It's not going to cost the teacher anything. Nice, clear, simple, and it's very practical. And finally, at the end of the activity, we want to have a wrap-up assignment to kind of bring everything back together. We really like the questions that Les used in his worksheet about the airplane. So we literally took a bunch of them, like what did they learn from the activity, what were they successful at, how did it apply to science, how did it apply to math. So we want to do lots of wrap-up questions, kind of bringing them all together. We want to have them complete their scale drawing of their kite at this point. And that's going to be basically giving them a piece of graph paper and a ruler and having them do some proportions, some calculations. And that is actually a job skill that's very important, we believe. And then we want to have some sort of conclusion, some sort of discussion of, okay, here was the simulation, here was real life. Does real life always match a simulation? How close does it match? And and showing them the real value of simulations, that generally speaking, simulations really lead us in a much less expensive and much simpler way to model what's going on in real life. We didn't have time to include it in our little unit, but we had lots of fun ideas of different things, and so did our mentor. We had some great ideas. Taking several targets and plotting out a coordinate grid, building a phone harness for the kite and mounting the phone, using the Google My Tracks app to chart its position over time, and using the GPS data to look at elevation. We thought about having a height competition, say whose height can get to 100 feet the fastest, or an accuracy competition where you'd have one person on the top of the school building sighting out flat, and everybody would try to get their kite exactly to that height by doing some math and calculating the amount of payload or extra weight they would have to add to the tail to get it to fly exactly that height. And another one we had was again the use of a simulation. We thought about having them go back to the simulator, even though they've already used it before, to take a look at their original design and to sit there and maybe take 30 minutes to an hour and just play with all the different variables and say, hey, was that really the best design? Did we get the maximum possible performance? And this is something that engineers do even after they build a product, even after they're done, go back and say, can we make it better? And we think that that would help students, again, to see the value of a simulator, to say, okay, we've taken this product, now we're going to improve it by just changing these different variables, and for extra credit or something, they could build a second kite. We thought there were several things we liked about our lesson. The simulator is very easy to use. The lesson is scalable. We could take it all the way to elementary, maybe just have them just build a kite and maybe not do too much math, all the way up through advanced high school students, maybe even above that. We can differentiate to our different learners by controlling the amount of math we're having to do, the amount of information that students are getting. It's easy to implement. Anybody can go to the store and easily find these materials, kites, and students already have cell phones. It's hands-on, not going to cost very much. I don't know about you, but I'm sort of a no-cost teacher. I've worked on no budget for 8 years now, and I'm kind of proud of that. You know, I'm proud of that fact that you look in my room and pretty much nothing there has been funded by the district, and I think that engenders pride in teachers, but we need to give teachers lesson plans that they can do that aren't going to cost them money out of their own pocket. And then we're going to use technology. Students like technology, and it's going to help them prepare for jobs because almost every job now uses a fair amount of technology. And so in keeping with that, with our cell phone theme, we actually designed a cell phone Android app to go with our project. And it's not finished yet, but we're in the process of building it. What it does is it's a program for teachers and for students, and the name of it is Aeroplans. And what it is it's a series of lesson plans and ideas, websites that apply to simulation and engineering. And so in the first box, they can type in their email address and then just hit send link right here, and it will send the link to their email. If they hit go, it uses the phone's browser and goes out to the website. And here there's a summary, just like a little, just 3 to 5 words about what the lesson plan is, and maybe some little details down at the bottom. I don't know about you, but I've spent hours reading the internet for lesson plans, and it becomes very discouraging. I just wanted something quick that could just get the teacher's hands on it and understand it. And there's a bunch of lesson plans in here I've got in here. They just hit next and go through a lot of them. And we're going to post ours here as well. And at the bottom, they can log into Twitter down here, and they can give us feedback. Oh, here's another lesson plan we really liked, or okay, your app wasn't so great, you need to fix something. But hopefully they like it, and they can use it, and who knows, maybe the students will actually find something to do with their cell phones that actually relates to math and science. And so we think that overall we've got a real practical, simple lesson plan for students to use that's going to apply to math, it's going to apply to science. We're hitting all kinds of these Common Core standards, and we think that students are going to enjoy it. I went out and tried it myself. I had a good time. I spent about an hour and a half out just flying my kite around. Had a great time, and I think that if the teacher's having fun, that's a recipe for success. Everybody's going to have a good time.
Oh, go back.
Oh, sorry. Excuse me. Okay. Our ideas for sharing our simulation information from this workshop and science, technology, engineering, and mathematics are right here on the PowerPoint. We have our Android phone app that we're in the process of developing. It's partially done. we're going to contact Popular Science. I contacted them. They said I could submit some information. The Flint Journal, Michigan Council of Teachers Mathematics newsletter, Michigan Science Teachers Association newsletter. These are all people that are willing to publish information about the workshop and about the work we're doing. There's a countywide math meeting at our county. There's a representative sent from each district, and in my experience has been they send pretty good teachers, and so I think we could talk to some teachers who are pretty respected in their communities and about this program, and they could spread that information in their districts. Mr. Lewis is a math coach, and he works with districts throughout the state of Michigan, and he will be sharing the information that we've gained from working with our mentor and here at this workshop with people all across the state of Michigan. And so we estimate that hundreds of teachers and possibly thousands of students will be impacted by the work we're doing.
Thank you.
Thank you.